Alright, before we get started here, let me remind you that this video will go extremely fast. If you ever have any problems, you can always pause and rewind and look at it again. Or you can skip through the section if you think you got it and get straight to the good stuff. I also like to remind you that the template for these notes are online on my website, and I'll write the website right up here at the top. It is drichusaf.wix.com/Mr. Richards. And if you don't know what that website is, I don't know how you got to this video. So here we go. First section is 7.1, nth roots and rational exponents. An nth root is defined as the nth root of a. I see n radical a, n is the index, a is the radicand, and we define it as the nth root of a. This means that some number multiplied by itself n times equals a. So far we've dealt with square roots, and we've seen that some number multiplied by itself twice would give you that number under the radicand. Well, now we're talking about nth roots. We don't know what that index is. That's what we're trying to find. So I'm going to do the first example. And after I work out example, if you want to pause it and attempt to work out the next example by yourself, that might be a good idea. If you wanted to see me work out examples, then you can keep going. Either way, at any time, feel free to pause and work out your own examples. So the nth root of 16 equals 4. This means that some number, we'll write as x, times itself n times equals 16. Well, I know what that number is because this nth root of 16 is equal to 4. So I can rewrite this as 4 to the nth power equals 16. Or 4 times itself, how many times? N times equals 16. Well, this is just 4 times 4. So 4 times 4 equals 16. So in this case, n equals 2. The next example, we're going to do the exact same way. I know that 3 is what this is equal to. The nth root of 81 equals 3. So 3 times itself n times equals 81. So I'll write this as 3 times 3. That's 3 squared. That gives me 9. That's not enough. So multiply by 3 again. 9 times 3 is 27. That's still not enough. So let's do times 3 one more time, and that gives me 81. So I did 3 times itself 4 times. So 3 to the 4th power equals 81. So in this case, n equals 4. And you could rewrite this as the 4th root of 81 equals 3. We have 2 more examples. Doing the same thing, I know that this is 2 to the nth power equals 64. So 2 times itself, how many times will give me 64? So 2 times 2 is 4. 2 squared is 4. Times 2 again will be 2 cubed. That's 8. Times 2 again will be 2 to the 4th. That's 16. Times 2 again will be 2 to the 5th. That's 32. And then times 2 one more time, which is 2 to the 6th, would give me 64. So we have 1, 2, 3, 4, 5, 6 times 2 to the 6th power equals 64. So in this case, our nth root is 6. And the last example is 5 to some power equals 625. So do it the same way. 5 times 5 is 25. That's 5 squared. 25 times 5, which would be 5 cubed, is 125. And then 5 again, which will be 5 to the 4th power, is 625. So 5 to the 4th power equals 625. So in this case, n equals 4, where the 4th root of 625 is 5. Now we're moving on to rational exponents. Before we talk about rational exponents, we need to know what exactly a rational number is. And rational numbers we've dealt with before, we usually express them as something that's p over q, where p and q are integers. And usually when we talk about rational exponents, we talk about fractions. So we're going to look at fractions. All right, so we're looking at fractions like 1/2, 2/3, 7/4. You know, although a whole number can be written as a fraction, like 8 can be written as 8 over 1, we're mainly going to be talking about rational numbers specifically, not whole numbers. So fractions is what we're looking at. So to show you where rational exponents come from, because again, we're talking about rational exponents, exponents that are fractions, let's look at the definition of a square root. So the definition of a square root, we're going to prove this. We're going to suppose or assume that the square root of a equals a to some power. Let's call it n. So a to the n power. We could use x. It doesn't matter. It's just a variable. That's what we're assuming. When we assume something, we want to prove that something is true. So we know that the square root of a times the square root of a equals a. That's the given. That's the definition of a square root. We're proving this. So I'm assuming that the square root of a equals a to some power. So I'm going to rewrite that. This is going to be a to some power times a to some power equals a. So this means that by the law of exponents, this is a to the 2n equals a. And this actually is a to the first. And by the equality of exponents, this might not be something we've talked about, but it's so obvious that you don't need to talk about it. If I have 2 to the 4th, and that equals 2 to some power, the only thing that makes this a true equation is for these exponents to be the same. So when you have bases that are the same, and you have two equal expressions, then the exponents also have to be the same. So this is going to be 2n equals 1. So in this case, n equals 1/2. So what does that mean? That means that the square root of a equals a to the 1/2 power. And if you want to write this 2 here as the index, you can, just so you can see the relationship. The square root of a equals a to the 1/2 power. If you think you're okay with this, you can skip the next example, but we're going to go over the definition of a cubed root. It's the same process, it's just this time it's a cube root instead of a square root. We're seeing if we can extend it one step further. So again, I'm going to assume that the cube root of a is equal to a to some power, a to the n power. And by definition, the cube root of a times the cube root of a times the cube root of a is going to equal a. This is the same thing as the cube root of a cubed, which would obviously be a. So I can rewrite this as a to the n times a to the n times a to the n equals a. And by the law of exponents again, I'm multiplying with the same base, so I add. So this is a to the 3n equals a. So this is 3n equals 1 because this is a 1 as an exponent. So in this case, n equals 1/3. What does that mean? That means that the cubed root of a equals a to the 1/3. Now I also know that the square root of a equals a to the 1/2. And if you keep this pattern going, because all math is patterns, if you keep this pattern going, you might see that the fourth root of a would be a to the 1/4. And you could probably assume by inductive reasoning what the fifth root of a is, the sixth root of a, the seventh root of a, and so on and so forth. So now that we see the definition, let's look at the definition of rational exponents. So if I let a to the 1 over n power be the nth root of a, I just proved that. Basically what I'm saying in this case is that a to the 1 over n power equals the nth root of a. That's what that means, that first statement. I'm assuming that is true, which I just proved it, so I know it's true. And I'm also going to say let m be a positive integer. Let m be some positive number. So here I have a to the m over n power. This is just my fraction. I could write p over q if I wanted to instead of m over n, since that's what we're used to seeing as rational numbers. But just to kind of denote the difference, we use different variables. It doesn't matter. The variables can mean whatever you want. So a to the m over n, I can rewrite that as a to the 1 over n times m using my laws of exponents. And I know that a to the 1 over n power equals the nth root of a. So now instead of a to the 1 over n power times, or raised to the m, I have the nth root of a raised to the m. And this is the main thing that you want to remember with rational exponents. You can also rewrite the nth root of a raised to the m power as the nth root of a to the m. Those are equivalent, and sometimes it is more advantageous to use this form as opposed to the other form. They're equivalent. Sometimes it's easier, sometimes it's not. It just depends on which way you want to go. So let's look at a couple examples. Again, we're moving fast. So if you feel like you need more help or you need more practice, just stop and do a couple problems. But I'm going to rewrite this as a radical. So I'm given a to the 5/3 power. And if I remember my formula, I have a to the m over n equals the nth root of a raised to the m power. So in this case, I have all my different variables. I have a equal to 8. I have m equal to 5. And I have n equal to 3. So I'm just using those different numbers and I'm plugging them in. So let's see what we get. So I have a to the m over n equals the nth root of a to the m. So this is going to be the 3rd root of 8 raised to the 5th power. So the 3rd root, or the cube root of 8, is 2. What number times itself 3 times gives me 8? Well, that's 2 times 2 times 2. So 2 raised to the 5th power. And 2 times itself 5 times is 32. So in the end, 8 to the 5/3 power equals 32. So we're going to do a few more examples. If you think you're good, you can skip to the next section. 81 to the 3/4 power. So example number 2. This is telling me that the a to the m over n power equals the nth root of a to the m. I'm not going to write out what each one of these stands for again. You can write that on your own. So we're looking at the nth root, or in this case, the 4th root of 81 raised to the m power, which is 3. Well, what number times itself 4 times gives me 81? That's 3. So now I have 3 to the 3rd. So 3 to the 3rd power equals 27. So in this case, 81 to the 3/4 power equals 27. Do a couple more examples. This is a negative number, so it's a little bit different. We have negative 27 raised to the negative 4/3 power. I'm going to do the exact same thing. Everything is going to stay the same with the variables. So this is going to, negative 27 is going to be under the radical. Oh, that's not right. I'm taking the cubed root of that, and it's raised to the negative 4 power. That's how you set it up. I can take the cube root of a negative number because a number times itself 3 times, I can get a negative. In this case, I get negative 3. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. So I have negative 3 to the negative 4 power. And what does it mean to have a negative exponent? Well, that just means you flip it. So it's 1 over negative 3 to the 4th. And 3 to the 4th, negative 3 to the 4th is 81. So this equals 1 over 81. It's positive because I have a negative, oh, I'm sorry,